Hey students, this is lesson 7.2 scientific notation. We're going to learn how to write numbers in scientific and standard notation and to compare and order numbers using scientific notation. Go ahead and do the vocab. You can check back for your answers. All right, is the number written in scientific notation if not explained? And on the vocabulary, we were given a very important vocabulary about scientific notation. To be in scientific notation, you have to use powers of 10, and you multiply some number times that. That's this a, and that a has to be greater than or equal to 1, but less than 10. So here's some examples. Notice that both those numbers are greater than or equal to 1, but less than 10. Notice that those powers are 10, and also notice that these exponents are integers. They can't be like decimals. All right. So let's look at these numbers. Is this number written in scientific notation? So in other words, is a greater than or equal to 1, but less than 10? And that is true for A. And then, are we using a power of 10? Yes. In this case, we're using a power of 10. And then, is this n, the power of 10, an integer value? And -6 is an integer, so we're good there. All right, so B, let's check that. Do we have a power of 10? Yes, we do. Do we have an integer exponent? Yes, we do. Is the number that we're multiplying by greater than or equal to 1? Yes. Is it less than 10? No. So this is not written in scientific notation. So that was a yes. This is a no. And the reason is because 12.9 is greater than 10. So, and then the last one, let's check that. We have a power of 10. We have an integer exponent. We have a number that is greater than or equal to 1 and less than 10. So we're going to say yes on that one. All right, go ahead and try problem number 1. Check back for the answers. Kind of convenient. We have the answers left from last year here. All right. So the next question here, writing a number in scientific notation. So we just have to make sure we write it like we just said, a times 10 to some power. The power needs to be an integer, the base needs to be 10, and the number a needs to be greater than or equal to 1, but less than 10. So if we're going to write this number, we're going to use 1.8 as the number a. That's a number greater than or equal to 1, but less than 10. Then we're going to multiply by 10 enough times to get the number 18 million. Now to do that, every time we multiply by 10, that's going to move the decimal over one place. So if I put the decimal here, I need to move it over 1, 2, 3, 4, 5, 6, 7 times. So that means I need to multiply by 10 7 times. Get that number. Okay. On the next one, we are going to have to make the decimal 2.0. So the decimal's there. And now, to get the decimal from here all the way to there, I'm going to actually have to divide by 10 a number of times. Every time I divide by 10, the decimal is going to move over one place. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I use a negative exponent, that essentially that's dividing by 10. So I need to divide by 10 times. So 2.0 times 10 to the negative 10. All right. I'll pause here and you can go ahead and try the next. All right. We're going to write these in standard notation. Now, for standard notation, what we're going to remember is that when we multiply by 10, that moves the decimal to the right one place, and when we divide by 10, that moves the decimal to the left one place. So, first one, the weight of the truck, we start at 2.8. We're going to multiply by 10 6 times. That's going to move the decimal to the right 6 places. So I'm going to have to fill in 5 zeros to get 6 places, and then I'm going to put in commas to represent that number, and that's 2,800,000 for that one. Now the weight of a paperclip, which is really small, we need to take 2, and the decimal point is right there for now. 2 is the same as 2.0, and we need to divide by 10 3 times, and every time we divide by 10, that's going to move the decimal to the right, or to the left one place. So I'm going to need to put 2 zeros in front of the 2 to make that number, and I'll write that like this, 2 thousandths. All right, go ahead, you can try that. Check back for the answer. All right, in this problem, we have 4 states, and we want to order them from least to greatest. Well, when dealing with scientific notation, especially if they're all positive powers, well, any powers for that matter, we can just order them according to the power, as long as the powers are different. So the higher the power, the higher the number. So this 6 here is going to tell us that Montana has the greatest area. And then for the 4s, we need to compare those two by their numbers. Whichever has the greatest number in front will be the greater number. And then 3 has the least power, so that it's going to be the least area. So if we order these from least to greatest, we're going to order them Rhode Island first, 1.5 times 10 to the third. Then 4.5 times 10 to the fourth. Then 5.9 times 10 to the fourth. And then 1.5 times 10 to the sixth. All right. Go ahead, you try it on the next one with negative exponents. It's the same. The higher the power, the greater the number. All right, just to talk about this a little bit, we know that this is definitely going to be the smallest because you're dividing by 10, 28 times, as compared to these two where you're dividing by 10 just 24 times. And then to figure out which of those are the smallest when they have the same exponent, just compare the numbers. All right, so here we're going to order them from least to greatest, and the problem here is that they're not using a consistent notation. So it would really help if we used all the same notation. So we could either put them all in standard form or put them all in scientific notation. And I think scientific notation is actually kind of nice for comparing. So let's take this 18.6, and we're going to make it 1.86 so that we have a number that's greater than 1 but less than or equal to 10, or less than 10. And then we're going to have to change the power. So we have to think about this. If I move the decimal 1 to the left, that means I need to multiply by 10 one more time. And when we're dealing with a negative exponent, multiplying by 10 one more time, actually, you would add 1 to the exponent. So we're going to make that 10 to the negative second. All right. Then 1.84 times 10 to the third. That one's good. That's in scientific notation. The 3.4, the 0.034, we need that to be 3.4. So again, we're moving the decimal to the right 2 places. When you do that, you need to multiply by 10 2 less times. So we're going to change that to 10 to the 0th power. All right. Now we can easily compare. We're going to go from least to greatest. The smallest power of 10 is going to be the smallest, so this will be our smallest number. Then the 0 is next in line, and then this one. And we're going to write them the way the original numbers were, though. So this number comes first, and the original number is 18.6 times 10 to the negative third. The next number is this one, and that's this, 0.034 times 10 to the second, and then the last one is 1.84. We can change that one times 10 to the third. All right, go ahead, you try that. I'll write some answers down for you so you can check your work. All right, so go ahead and check your work there, and we'll do the lesson check. All right. Reasoning, a student claims that 3.5 times 10 to the 11th is greater than 1.4 times 10 to the 13th because 3.5 is greater than 1.4. That's true. 3.5 is greater than 1.4. But I don't think it's true that 3.5 times 10 to the 11th is greater than 1.4 times 10 to the 13th. And my reasoning is I think multiplying by 10 13 times is going to be greater than multiplying by 10 11 times, especially if we start with the same numbers in the same place value, which we have here. And just to prove that, let's go ahead and write these in standard notation. To do that, this 5 moves the decimal over 1 place, and I need to move it over 11, so I'm going to add 10 more zeros. I think I counted right. Hope so. So we get 350 billion. Okay, and then 1.4, I'm going to go 1, 4. And so I've used up one of these powers with the 4. I need 12 more zeros there. And that gives me 14 trillion. All right, and obviously 14 trillion is bigger than 350 billion. So we're going to say no, the reasoning was incorrect. And I would say that this number is going to be greater because these both are written in the same place value, but multiplied by 10 13 times. 13 times is greater than multiplying by 10 11 times. All right, that's the lesson. I'll see you tomorrow.